Next up, we've got our first keynote panel of the day, which is going to be discussing how data center ecosystem is keeping up with AI demand. So please join me in welcoming our moderator, Andrew Jay, Executive Director of CBRE, and all of our panelists to the stage, please. Thank you.
Good morning, everybody. I'm Andrew Jay with CBRE. We have been asked to discuss how is the data center ecosystem keeping up with AI demand. And I think this should be quite a good scene setter for this year's Data Cloud when we consider that there's probably around 100 gigawatts of current IT power in the world, and of that, around 60% is accounted for by the hyperscale companies. Traditional workloads account for probably 30%, and the remainder 10 to 13% is AI workload. So, thank you very much. The kind of punchline to that point is the projection is for the AI workload proportion to increase to 30%, 30%, by the end of 2027. So that's broadly in 18 months' time. So I mean, that's the thrust of this panel. We're going to discuss cloud versus AI demand. We will talk about AI inference. Is it coming? Are we transitioning towards inference yet? And how is Europe keeping up with this demand for AI infrastructure? And then we'll look at some of the design elements as well. So what innovations are we seeing around data center design? Are they changing to accommodate AI, particularly the neo clouds? And if we get time, we're going to touch on enterprise adoption of AI. And so to help us with these important questions, we have got a fantastic team of leaders. We've got two developer operators, global and European. We've got two of the global equipment manufacturers. Thanks for joining, guys. And we've got Oracle as an end user, Matt. So, gentlemen, would you like to introduce yourselves, and then we'll get going?
So I'll start. Frédéric, I lead energy management at Schneider Electric, 35 years in the company, and as you can imagine, exciting time ahead for energy. So pretty happy about the future and what it looks like.
Hello, everyone. Gio Albertazzi. I'm CEO of Vertiv, global leader in, as I say, digital critical infrastructure, everything around infrastructure of data centers, and AI data center, traditional data center, across the entire spectrum.
Good morning. My name is Tag Greason. I'm co-CEO of QTS Data Centers. Happy to be here. Looking forward to the conversation.
Morning, everyone. Matt Souders, SVP of Data Centers for Oracle.
Good morning, everybody. Olivier, I'm running Data4, which is a pan-European data center platform. Very pleased to be here today as we're celebrating our 20 years anniversary this year.
That's impressive. Thank you, Olivier. So we're not going to talk about power. Power is table stakes for everyone, and power is going to be discussed in detail in other panels over the next couple of days. But, Frederick, on our briefing call, you actually had a very sort of positive view of how AI can be used to make the world much, much more efficient in terms of power consumption. Perhaps you'd like to just start off with those comments.
Yeah, maybe to start with a bit of a different view on AI. Today, AI is consuming roughly 1% of the energy of the world. And what I was saying when we prepare this panel is that there is 99% that are other usages. And those 99% of other usages can be completely optimized by AI solutions, especially in terms of energy usage, energy reduction. I can give one example because we're here in Europe. What we believe achievable in Europe is a possibility to shave the peak of demand of 172 gigawatt by using AI technology to manage the peak time and rebalance the loads in areas where the usage of energy is not critical at any point of time, in homes, in buildings, in part of industries. So by doing so, there is a lot of discussion on power, and then you say we're not going to go there in this panel. But we would like to insist on the fact that AI is highly part of a solution to a better usage of energy in the future.
I think that's fantastic. I think the more people who are aware of that and have that kind of top of mind discuss that point about AI, the better probably for all of us. So let's dive into demand. Tag and Olivier, I'd like to understand what you're seeing from an overall data center demand perspective, and particularly how it is splitting between AI and cloud workloads. And to what extent are the hyperscalers satisfying their AI demand themselves versus using neoclouds? So perhaps Tag, kick us off.
Jay, thank you. So when we see on the demand side of the equation, very clearly AI is additive to what's happening in the demand side. And what we mean by that is all the cloud service providers, and Matt can certainly speak to this directly, all the cloud service providers are still providing the same 20, 25, 30% growth for their cloud services that they have been for the last decade or more. And AI workload is on top of that already 30% growth of their cloud services. It is not replacing those components. So when you think that AI is new, it's additive. That's point number one. Point number two is you then have the mixture of the cloud services that have been there for many, many years and the AI services, which are broken up into training workloads or inferencing workloads. And as you think about the geography of where these are, most of the training workloads at scale are in the US, but I think that the inferencing workloads will quickly come and be at scale here in Europe. And so the demand is continuing to go up. The reasons are AI is additive. And as training develops, inferencing develops, we'll see those workloads move into the European markets at scale. And when we mean at scale, from our perspective, we're talking 300, 400, 500 megawatts on a campus, not 50 megawatts in Frankfurt. That's still a cloud services offering. And so that additive scale and the diversity of training and inferencing is what Europe is about to see in the next 18 to 36 months.
And have you, Tag, have you actually seen any of those scale of deals from your point of view? Obviously, I know you tend to go big and you've got some big sites in Europe.
Yeah, we have. We have 5 sites in Europe. We have one in the UK, one in Spain, one in Italy, one in Finland, and one in the Netherlands. And the size of the opportunities there range from 130 megawatts up to 700 megawatts of critical power. And we're seeing the demand from the hyperscalers to take advantage of that power that will come online in 28, 29, 30, and 31. And so that kind of scale is something we've never seen in Europe before, but it is coming, and it is something that we all should be prepared for.
Olivier, your thoughts?
Yeah, so I will give a European flavor to what Tag has just said. I mean, the demand is super strong, super high. I guess you saw the announcement yesterday from SoftBank for an investment of $75 billion, euros, whatever you want, in addition to the 110 billion that have been announced 1 year before, which shows that basically the demand is there. I agree. It's additive. Already until 3 years ago, the demand was super strong from a business cloud perspective. And then when you add the AI, the period we're living, that's why we have so many people here at this event. The period we're living is historical. And we have on our shoulders, we need to build that. We need to supply, basically, to cope with the demand. And knowing all the challenges, and I'm sure you will come back on that, it's quite difficult. But to come back on the demand, what we're saying is 80% now of the demand from our side is AI related, so which is very big. And I agree with TAG, it's much bigger. Basically, they need very large campuses. So at Data4, our bread and butter is 250 meg. Now we are more working on 1 gigawatt development to match with the AI demand. So it's very big, it needs to be delivered very fast, and as well in geographies where the power is very competitive. Because it's not just the data center, it's the data center plus the power, it's the addition of both, which give, if you want, the cost of your token, of your cost of your stack. And that's why you see areas like the Nordics that are super dynamics because the cost of the power is very competitive. You see as well France because it's, of course, decarbonized and it's very competitive. You see Portugal as well because it's competitive and it's decarbonized. And you see these areas in Europe that are popping up because they match very well with very large scale AI rollouts and it's super competitive.
And you mentioned 80% of demand that you're seeing is for AI. Could you give me a view of how that splits between actual hyperscale end customers contracting with you versus the neoclouds?
Actually, we have, I would say, 4 growth relays in Europe. So we have what I call the traditional hyperscalers. Their demand is obviously very big. And they need as well in the existing metros because they need to grow their existing AZs or the existing cloud, let's say, nodes, hubs. So that's obviously a very big demand. We start having in Europe, and that's a good news, some large AI companies. We talk about Nenscale, Mistral, few, but they are growing. And we start having some demand from those guys, Nebius as well. And then we have 2 growth relays. We have the neoclouds, but in general, the neoclouds, the traditional neoclouds need between 10 to 30 meg, as opposed to other hyperscalers that needs to 200, 300, 500 meg. And we see as well the Chinese hyperscaler. And because it's more complex for the Chinese hyperscaler perhaps to develop their business in the US, Europe is for them a key area to become true global brand. And so that's why you see as well the Chinese hyperscaler being very offensive in Europe. And that's the 4 growth relay we're seeing in Europe.
Makes total sense. And what about inference? So yeah, we've been talking about inference now, from my point of view, probably for 3 years. I've not seen a fat lot of tangible evidence in Europe yet. So what about you in the Data4 facilities?
I would say most of the projects we are working on are for inferencing. That's what our customers are basically saying. Now, after that, it's fungible as well. What they need, it's fungible data centers, which means that it's for AI, okay, for inferencing, but it could basically as well address, the training part. And if for any reason AI is slowing down or whatsoever, they could use these assets as well for their cloud requirements. So they need some flex in the way we are building the data center because we never know how the future will look like. And one of these things, AI, can slow down and then they could use it for cloud, basically.
Makes total sense. TAG, inference, what are you seeing?
Yeah, I absolutely agree that the diversity of the compute power that is delivered by the developers has to be able to support different versions of cloud, inferencing, and what the new term that I'm starting to hear more of, private training. So now all of a sudden, think of a training development that is specific to an enterprise. And that is going to be the way to unlock training in various locations and not having to build a single 300 or 400 megawatt training campus, but creating the opportunity to, in one single campus, do cloud services, inferencing, and private training, which I think is going to be a next generation of use case for enterprises as that adoption continues to increase.
Yeah. Matt, can I bring you in here? So Oracle, fantastic. You know, you've gone long on cloud some years ago. You're going fairly long, I'd say, on GPUs. What are you seeing?
So the demand continues, obviously, to outpace supply, right? So we are growing across the world. In Europe specifically, it's going to depend heavily on competitiveness of power and speed to market, but we're ready and prepared to grow with our customers here.
And what about the inference side? How do you deal with inference versus the training workloads?
We're seeing pivoting at scale for inference. I think we'll go into it a little bit later, but the key here is having designs that can easily pivot between, leaning in, having sites ready, working with our customers to determine if it's a training or inference site. Okay,
thank you. And I'm just finishing off on the inference point, on the, I guess, the sharp end for you guys, Vertiv and Schneider. What are you seeing? Are you creating new products for inference? Do you actually see inference as a separate thing, or should we not think of inference separately from training?
I would say that along the lines that we just heard, inference is absolutely central to the infrastructure that is being built today. Fungibility is key. Yes, there continue to be some data centers that are specifically designed for large model training, but more and more what we see, and we have seen it for a year, or probably a little bit more than that, almost 2 years, our customers say, hey, we need flexibility. So it's almost as if when it comes to the powertrain, the thermal chain, what the exact use in terms of AI that data center will need to enable, perform, is I wouldn't say irrelevant, because some architectures may be slightly different if it is an extreme use on one side or the other. But more and more we see a hybrid or an infrastructure capable of managing both. What we see, of course, is a rapid evolution of the technology of the servers, the GPUs, and that, of course, drives evolution in thermal management, in power management, and the dynamics are very, very accelerated. And of course, that creates a lot of opportunity. And a lot of opportunity also, going back to what we were saying about energy and energy use. The opportunity is to make a better use of every electron that is available to that side, making sure that the vast majority of electrons really go to the GPU and not used to other type of users.
Yeah, just to add on what Joe was saying, I mean, we have a scarcity in the medium term of compute and of power. So optimizing all that is extremely essential. And being data centers that are by design versatile is extremely important. Last comment is we're at the beginning of the adoption of inference at scale. Today is not largely at scale. We discuss with a lot of other large companies, and I look inside Schneider as well on the adoption of AI. We know the potential. We're at the early stage of the curve. So on the midterm, there will be more inference for sure. But for the moment, you have a scarcity of power and of compute. So you need to build infrastructures that are made to use the best of what is available.
And Jay, if I could, one of the things that I think it's important for all of us to remember is the data center, while can be very complicated, which we'll talk about in delivering, operating, and designing, is relatively simple in concept. There's power that comes in, power is used through the computers to generate heat. The heat has to be expelled and the data center has to be cooled. 20 years ago, this stage would have been talking about the adoption of IT workloads from the enterprises coming into the data center. 15 years ago, this stage would have been talking about streaming services and or online learning or some other. 10 years ago, cloud services. Today, we're talking about inferencing. Tomorrow, we're going to talk about training. And in 5 years, we're going to talk about quantum computing. And so I don't want us to get too wrapped up on what's actually inside the data centers, to your point, Gio, about whether it's relevant or not. The point of the data center is to take energy in, it generates heat, and expel that. That will always be the same. Inside the white box, the density might change, the cooling apparatus might change, the technology might change. But I get the question all the time. What happens to all these AI data centers if there is a downturn or a bubble? Nothing. They continue to generate exactly the same compute power for a new workload that we may or may not be talking about 3 years from now.
Yeah, and at an increasingly large scale. So on the equipment side, Frederick, Gio, are you guys keeping up? Can you manufacture enough kit to support the data center builds? How do you think Europe?
That's a great question. Can you help?
Look, we're keeping up. I was listening to the previous panels, and the place where we're working harder is on competencies. I mean, the supply chain in itself is keeping up. I mean, we were under tension 2-3 years ago. We're still under tension. But what is the most important thing now is competencies, people, and speed. Speed of the supply chain. There is capacity, but how you activate this speed, how you ensure that you internalize in factories some of the operations that were done before on site. So that's what we do with prefabricated modular manufacturing. By the way, yesterday we were announcing the support to the SoftBank project in France to be able to build prefabricated module, something that we did in a matter of weeks to be able to cope up with the demand. So competencies now and lead time is probably more important than capacities that has been ramped up.
Okay, well, we'll turn to the
let
developers in a minute,
yes.
but Gio next
Yes.
on Vertiv.
Yes, thank you. No, I agree. I mean, it is not just capacity. Capacity is being built. In our case, capacity is being built at speed. And it's not just our capacity, it's the capacity of the supply chain. But as you were saying, it is about a transformation of the industry. So going from, let's say, snowflake data centers to really kind of think at a scale the way you build, bring from the site to the factory, manufacture the entire data center as much as possible and deliver that speed. But then I say also the optimized design that, if you will, not always is possible. The optimization levels that are not always possible when you operate on site. Sites are very big, are very complex. They require a lot of skilled labor, not always available. So there is a multidimensional transformation. There's a technology transformation, capacity transformation, and a way of building transformation all happening at the same time. And it's so much fun being in the industry now. You can't even believe that.
I'll add on, one of the biggest challenges we're seeing with equipment now are startup technicians, right? The amount of boxes that are shipping and being commissioned, it's quite a challenge to have the right people on site and start up and commission the equipment.
Yeah, and if I may, super true. So that's why some of the technology providers have the ability to scale not only a shop floor, not that it is easy, but scaling a global service commissioning organization. Sure. Sometimes you can look at it as a different order of magnitude complexity. So not all the players on the technology provider side can do that.
For sure.
So net, Olivier, do you think Europe's keeping up with demand at the moment?
Oh yeah, definitely. I mean, the demand, as I stated at the beginning, is very high. Europe is catching up. I mean, I had a very interesting breakfast with an international bank this morning, and the analyst said something which is very true, is in terms of supply, or if you want supply and demand, it's 10 times the US compared to Europe. It's very simple. You have between 10 to 15 gig in Europe. It's about 50 gig in the US. And with a population which is basically 40% lower than Europe. So on a citizen basis, basically the megawatt is 10 times lower in Europe or 10 times higher in the US, and why you have that is because the majority of the data of the Europeans are not hosted in Europe, they are hosted in the US, which is a nonsense. And so that's why basically you have a catch-up in Europe, definitely, because as well we start having some challenges. I was jealous, actually. I was seeing a gigawatt in Texas and a gigawatt there, where in Europe you try to deliver 200 meg, it's very complex. And now I start seeing that you have more complexity in the US, and by definition, the workloads will be, for the Europeans, will be hosted in Europe. Why doing the training or the inferencing of the European? Inferencing will have to be close from the Europeans anyway, but why doing the training as well over in the US where you could do that in Europe? So, I mean, the perspectives are very strong. I think we have, from our eyes from 25, we see a 20% CAGR for the next 5 years, which is about 2.5x compared to 25. But this is with the eyes of 25. So with the eyes of 26, I'm sure it will be higher, etc. And so the challenge again is how to supply, how to deliver this amount of capacity in, I would say, a record time. Because if it's to be delivered like in Amsterdam by 2035, or it's to be delivered in 5 to 7 years, the problem is AI is being written now and not in 5 to 7 years. And that's the big challenge. And that's why I was stating at the beginning, we need to find the right spots in Europe where you have the power that can be delivered quite rapidly, and if possible, at a cost which is very competitive.
Yeah, I agree with all those comments. And your investors, they're not going to be happy with 20% CAGR, Olivier, for much longer. Tag, do you subscribe to those comments? Particularly, you've got the US perspective where things are at a different scale.
I do, absolutely. So 2 things I might offer to the audience to consider. One, way back in history, like 5 years ago, we used to build data centers in a very specific way. You would buy a piece of land, and you'd stop. And then the next week, you pick up the phone, you call the power company and say, hey, by the way, do you have any power? And they say, yep, we've got power, because for 4 decades, they always had power. So you didn't have to worry about that. Stop. Then you hire a general contractor. They start building the building. Just stay with me for 1 second. They're building the building. It's coming out of the ground. And then you think about supply chain. This is 5 years ago. Then you order your supply chain. And then at the ribbon cutting, you introduce yourself to the mayor of that city and say, I just built this beautiful data center in your city. I'm so glad to meet you. Thank you for coming to this ribbon cutting. If anybody did that today, your project would die. You have to now do land, power, supply chain, labor, community engagement, and you have to do it about 3 years early. That is a huge investment, and we're seeing that across the United States, and Olivier, we're seeing that, as you were articulating, here in Europe. And then, lastly, take that from a 50 megawatt deal to a 500 megawatt deal. And everything just got that much more complex. And so that's the trend that I see that we've seen in the United States. We're delivering 4 1 gigawatt projects right now, and we're working on the scale that we talked about here in Europe. Getting to a gigawatt project in a single location in Europe, I think is going to exponentially change the complexity of the business across the board.
And when we were doing our prep call, Tag, it was really interesting. You called out community engagement as one of the key factors, and Noel and Rachel talked about it as well. Just talk to me about how important that is. You made some quite funny comments about battles that you've got to face and how that works.
You know, for QTS and I'm sure other providers, community engagement is the #1 issue. Power is difficult, supply chain is hard. You heard the water constraints. Certainly getting the right equipment and getting it deployed, all of those things are very difficult. But the make or break of every project today is community engagement. And there is a saying in the United States that may or may not, Olivia, I'd love to know your opinion. There are citizens out there that we call cave people that are in caves. It sounds very derogatory, but it stands for Citizens Against Virtually Everything. It doesn't matter what you're doing or why you're doing it or how you're doing it. You could build a church and someone's going to be against it. Now build a gigawatt campus and a lot of people are going to have an opinion. If you aren't in that community early and aligned with the needs and the stakeholders of that community, your project will likely fail or be delayed. God gave us all 2 ears and 1 mouth. When we go to community, we should listen more than we speak, and we should talk about what their requirements are. And if you don't, the scars that we had a project in the United States, we had 8-to-1 vote in our preliminary hearing, and 6 weeks later, we had a 6-to-3 vote against the project, and each one of them had received outside opposition, people who don't live in that community, that came into the community to tell them that they shouldn't build this project. I would rather have that no vote before I put €1 billion into the ground and understand that. So having that early indication of what the community is or isn't going to do is critically important.
And just give me a quick view on these moratoria that we're hearing about specific to the US, because we've got some examples of that in Europe, but I'm hearing a lot of different stories for the US.
Yeah, I would say 8 months ago, the fog of war was very cloudy. We couldn't decide which communities wanted data centers, who didn't want data centers, which parts of the country, same as in Europe. Today, everybody's made a statement. We don't want your data center. Or, we'd love to have your data center. And we're totally fine with that opinion. I would just like to know up front which side of that equation you're on so that we can decide where we want to deploy. So in the United States, where there are bans, no problem. There are plenty of opportunities for communities to saying, I would love for you to come and invest $10 billion into our community. Thank you for coming. There are areas in the communities in Europe, same way. So as an industry, I don't think we should force our way into a community if they've said, no, thank you. I think we should be very open to working with those communities and understanding how we're going to get this project done and ultimately invest the capital required.
So when we're doing site selection work for people like you, we should have a check on where the cave dwellers live, and then we should be sort of mapping that and going for the areas with the least cave dwellers.
100%.
I love it. Olivier, a Frenchman building data centers across Europe, but starting in France. I suspect you've got a bit of advantage, haven't you, on this with your local knowledge?
Well, that's true. As a European company, it helps when we go into the communities, the territories, basically to propose our project. But just to come back on what Tax said, what I found is there is no nuance now. It's either black and white. I love, or I don't like. And to be honest, what is very strange is I thought on the color of the political guy at the community, they would be more pro than anti. And actually, I've got some guys at the far left that are pro data center, and guys on the right side that are more, business oriented that are anti data center. So I agree. When you do a project, go and see the community and check if they are pro or open to. But if they are anti-data center, forget it. Do something else, but because you will never succeed. And we have some cases like that. Just about the local stuff. The data center is a critical asset. It is a critical infrastructure. But one of the building blocks is real estate. And so you need to have authorizations for environment, building permit. And so basically, you need to get the power as well. So you need to be very local. You need to speak with the TSO, the DSO. You need to speak with the community, with the administration, the government, the ministers, etc. And so that's why you need to speak in the local language, basically, to be in a position to deal with all these matters. And that's why when people ask me, but how do you pronounce your company name? I said it's Data Quattro, Data Fir, Data Tessera, Data 4, because actually we are extremely local, and this is the only way, from my perspective, to succeed now in our business.
Yeah, so I suspect we're going to see more joint venture type arrangements, particularly with some of the US and Asian folks coming to Europe to get over some of these problems, or at least help with some of these problems. Matt, do you have to worry about these types of issues at Oracle?
I'm so happy to work with the people on this stage because I'm pumped. Like smart, good stuff. Thank you. Yeah, of course, we have to worry about all the same things, right? And to echo what was said on the stage earlier, right? You have to be a good citizen. You have to support the community. You have to be knowledgeable about where you're going, the challenges and risk, and be prepared for those, right? It's just like anything else in life. The more prepared you are, the better you'll do, and hire smart people. Okay,
so we're going to move on now to design for AI. So I've heard a lot of stories, indeed clients of ours saying, yeah, we want flexibility to go up to at least a megawatt per rack in the future, and we want to flip-flop our workloads from cloud using air to DLC, liquid cooling. Can you sort that out for us? Are you seeing that tag, Olivier? And if so, I guess the punchline is, who pays for it?
Yeah. Alors, the 1 megawatt per rack, not yet at the moment. But what we're seeing is indeed a kind of mix of requirement. And we build data centers, by the way. We just delivered the 30 meg DC, which is basically hybrid. We do for cloud, and we do for, and we have DLC as well to provide, to host, AI workloads. So we are able to do that. But again, what they're asking is, as I said at the beginning, is some flexibility and assets or data centers that basically can vary depending on where the demand is going. So again, you can build an air-cooled data center that needs to be adaptable, that can basically be reviewed basically to host AI workloads. So you need to have the right height, because if you start putting DLC water on top of your racks, then you need to take that in consideration. On the plain floor, on the floor as well, you need to be in a position to as well host racks of multi-tones, because it's super dense. So you need to integrate that in the design of your data center, but there is no reason now today why you can't adapt your data center to be either for cloud, training, inferencing. You can adapt that straight from the beginning of the design of your data center.
And yes, go ahead, Tag.
One of the things that to Olivier's point, which is right on, 2 years ago, 90% of our data center workloads were air-cooled. And 2 years from now, 90% of them will be liquid-cooled. We're in this very interesting spot in our industry of conversion. And the hyperscalers, and Matt maybe can or maybe comment or not, but there is a conversion now where the conversation is, I'm not sure exactly what my mix needs to be, so I need you to be prepared to do 100% air and 100% cooling, because I'm not sure what my mix is going to be. I'm not good at math, but that sounds expensive. So we can certainly decide that it's going to be, flexibility is going to be expensive. The number two part about your point about megawatt racks, they also want to future-proof the environment. So today, this room can hold 15 megawatts. Let's just say one small data hall. But they don't know if they're going to need to put 25 megawatts in that room 3 years from now. So we're building air and liquid, and we're future-proofing the density. And then we get a comment that says, and the fit-out cost used to be about $3.5 million per megawatt to fit out the room. And what I just described is $7 million a megawatt to fit out the room. And so ultimately, who's going to pay for that? It's going to be the end user if they do want to future-proof and buy flexibility into that environment.
And what magic are you guys working, Gio and Frederick, on the equipment side?
Well, clearly, as described, the direction in which technology and density is going is clear. Higher and higher density, liquid cooling, but it's not just about liquid cooling. It's about the power infrastructure is going to evolve. So we all hear about 800 volt DC, a very important evolution that goes, let's say, hand in hand with higher density. But as we heard, you can't even think about a data center, all data center created equal, all having exactly the same purpose in life or life cycle of the asset. They will really respond to the business need of the hyperscaler, the neocloud, or the developer operator. And you will have an array. There will be, and there are today already, very focused data center designed on a specific GPU. Over time, they will need an upgrade to higher levels, but think about the entire spectrum. Technology is evolving. It's evolving in terms of coping with a high density, of course, and that's not just liquid cooling. It's the liquid cooling air mix, is all the complexity in the mechanical yard, the heat rejection that needs to cope with the range of water temperatures that is evolved. There's much more technology today. And I go back to the powertrain, in which we will all have to make sure that we give our customers a choice between more traditional type of powertrains that are AC power based, but that can all the way feed and run DC power racks and servers, or go all the way to an entire end-to-end 800 volt DC. Again, trading off flexibility with focus and optimization. It is very important that players like Vertiv, we have not only the entire portfolio, but also that we are agnostic about one or the other technology and really sit with our customer and say, what is the business objective? And based on the business objective, we can make the right technology available. Super important.
And do you envisage people are actually going to, having installed their GB300s, they let those run for X number of years, do you see them likely to swap out a lot of the powertrain and the cooling, et cetera, to accommodate then the next generation? Or do the GB300s just going to carry on?
Well, there will be typically probably what we foresee, because that kind of IT refresh cycle hasn't happened yet. But what we see is a gray space infrastructure, staying pretty much the same, and having a white space, including the liquid cooling, the rack level, white space, power distribution, and voltage adapting to the next and next generation.
Frederick?
Yeah, few elements to complete what Joe was saying. What we work on is for sure direct current architecture. Okay, we know it's the future. It's a place where we need to evolve technology, but not only technology. We will need to evolve regulation, because today the regulation to manage at scale direct current needs to evolve as well. Most installations today are in alternative current. All regulations are in alternative current. So we will need to work on the regulation, on the standard, on the way to train and have safe installations for the people who operate them. The second place we work hardly on is software. Because what you were explaining very well is those data centers in the future will need to be more versatile. We need to be more able to be controlled. The power of each rack is super important. When you have more density, you have more compute capability. Software to manage the density, to manage the energy, to manage the cooling is extremely important. So having one platform that allows you to do that, and doing simulation on top of this real-time platform is a place where we absolutely want to help our customer so that you design, you simulate, and then after you install and you operate. Now the variance between simulation and operation is decreasing, means what you simulate is extremely accurate.
Fantastic. We are at time, so thank you very much indeed, gentlemen. We've got through virtually all of our questions. I'm very grateful. Thank you very much.
Thank you.